Start now. Today students will study about, under Nuclei we will study about nuclear energy. In nuclear energy, first we need to understand the graph. We'll start with the graph. Certain graph, this particular graph will show us a relationship between binding energy per nucleon. Binding energy per nucleon. EBN, that will be equal to the total binding energy of the nucleus divided by the atomic mass, number of nucleons in a single nucleus. Here in this graph we want to show a relationship between the binding energy per nucleon and atomic mass. Our graph will appear to be like following. This particular graph, the binding energy per nucleon EBN is maximum for atomic mass greater than 30 and less than 170. For A greater than 170 and for A less than 30, molecules, the nucleus of these elements have a tendency to, if let's say if it is a heavy nucleus, then they are unstable. They have a tendency to convert itself into two nucleus of lower atomic mass. For example, in fission, nuclear fission, the heavy nucleus of 92U235, a uranium isotope, when a neutron interacting with the nucleus of uranium-235, then the nuclear fission will occur. We'll get 92U236 and this uranium will break itself into barium 56 144 plus krypton 36 89 and we'll get 3 neutron plus approx 200 mega electron volt energy. So the nucleus with greater atomic mass is breaking itself into two small nucleus or two nucleus with a smaller atomic mass, and in the process we are gaining in binding energy. For example, the EBN for atomic mass 240 is, let's say, 7.6 mega electron volt, and a nucleus EBN for A120 is 8.5 mega electron volts. In this process, when nucleus with A equal to 240 breaking into two fragments, okay, each, let's say, with A 120, then in this process we are gaining In this process, gain in binding energy will be 0.9 mega electron volts per nucleus. Total gain will be, this is gain per nucleons. The total energy will be 240 into 0.9, that would be approx 216 mega electron volt, which is itself is a huge. After understanding fission, we'll see how the nuclear reactor will work. How the nuclear reactor works. It's a ray diagram of nuclear reactor. We have a core, we have control roots, we have a layer of reflectors. Inside the core, the nuclear fission is taking place, and the control rod will control the process. The energy from the process, we get it through the coolant. We are getting this out of the core through the coolant. This is core, these are control rods. Okay. This is a reflector. This is a coolant. Then the energy from the coolant will be transferred to water, and we are getting steam, which is going to turbine. Will be the steam generator. The steam generator, we are sending the water, which is later on converting into the steam and going to turbine. And later on, the coolant will again send back to the core. So this process is nothing but a different way to convert water into steam. We are using controlled nuclear fission energy to convert water into steam, getting energy out of it. The heat energy is converting into mechanical energy, the power of the steam, and then mechanical energy is turning the turbine and is generating the power for us. So this is the nuclear reactor in brief. After that, another form of nuclear energy is nuclear fusion. The controlled nuclear fusion is not possible on Earth. This takes place in nature inside the sun. We have following equations: two protons converting themselves into neutron and positrons plus neutrino and energy. We have few other equations or reactions which taking place. Two protons converting into neutrons, 1h2 plus positrons plus neutrino plus energy, neutron later on converting into helium, the nucleus of helium plus neutron plus energy. They are also converting themselves into deuterium, and proton plus energy. Let's say it is the equation 1. The positrons and electrons together are converted into gamma rays. That is another form of energy. Equation 2. A proton and neutron converting into the helium and gamma rays, equation 3, 2He3, two nucleus are converting themselves into 2He4 plus 2 protons plus energy, equation 4, by 2 into equation 1 plus 2 into equation the following equation, the combined equation, 4 protons, 2 electrons, they are giving the helium nucleus plus neutrino plus gamma particles plus 26.7 mega electron volt energy. The estimated temperature for nuclear fusion is approx 3 into 10 to the power 9 Kelvin, at which two protons have enough energy to overcome the Coulomb barrier. This energy is not possible other than Sun and in atom bomb. Thank you.